Greetings, Calc 2 students. This video is for section 10.11, and we're going to work out homework example number 13 in our book. This question asks us to find the Maclaurin series for f of x equals cosine of x, and then it also asks us to find the radius of convergence. So remember, for Maclaurin series, we are interested in mostly finding these coefficients c sub n, and that's equal to the nth derivative evaluated at a over n factorial. And for a Maclaurin series, this is a special case when a equals 0. So my solution then is I work out the first few derivatives of cosine of x and evaluate them at 0. So I'm trying to figure out what the pattern of the coefficients are. So the first thing I did was f of 0, so cosine of 0 is equal to 1. Then I took the derivative of cosine and got minus sine, evaluated at 0, and that's 0. Second derivative is then minus cosine, evaluated at 0, is negative 1. Third derivative is sine, evaluated at 0 is 0. Fourth derivative is cosine, evaluated at 0 is 1. Fifth derivative, minus sine, evaluated at 0 is 0. Sixth derivative, minus cosine, evaluated is negative 1. So I see this pattern that with the even derivatives, the 0th derivative, second derivative, fourth derivative, and sixth derivative, I have this plus 1, minus 1, plus 1, minus 1 pattern happening. So even derivatives give me the pattern of 1, minus 1, 1, minus 1, and so forth. So I wrote this out then. The cosine of x is equal to 1 over 0 factorial times x to the 0th. So the first even number is 0, so 1 over 0 factorial times x to the 0. And then the next even number is 2, so I have minus 1 over 2 factorial times x to the squared. Then the next even number I have is 4, so back to positive, 1 over 4 factorial times x to the 4th. The next even number is 6, so back to negative, minus 1 divided by 6 factorial times x to the 6, and I keep on doing that. So if I simplify that, I get 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial. And if I write that out in general, how do I write an even number? Well, remember that an even number we can write as 2 times n. That's an even number thing. So I want even number things. So this is going to be 2n and then factorial. That's the even number part. And this is going to be x raised to the even number, so 2n. And then now I just need the series to alternate from positive to negative to positive to negative. So I write out front minus 1 raised to the n. And that gives me the positive, negative, positive, negative. So my cosine of x is equal to the summation from n equals 0 to infinity of minus 1 raised to the n multiplied by x raised to the 2n divided by 2n factorial. Now the second part asks us to find the radius of convergence. So my a sub n is equal to the minus 1 raised to the n times x to the 2n divided by 2n factorial. And my a sub n plus 1 would be minus 1 raised to the n plus 1 times x to the 2 times n plus 1 divided by 2 times n plus 1, and then be careful here, the whole thing is factorialed. So remember, if I take the limit of the absolute value of a sub n plus 1 divided by a sub n, and that limit exists and it's less than 1, then my series converges. So I took a sub n plus 1 and divided it by a sub n and took the absolute value, and I did some algebra first. So this is a sub n plus 1, and I multiplied that by the reciprocal of a sub n, and then I took the minus 1 raised to the n plus 1 and wrote that as minus 1 raised to the n times minus 1 raised to the first. Then I took the x raised to the 2 times n plus 1, and I wrote that as x to the 2n times x to the squared. Then I still have this 2n factorial, and recopied the bottom. So now this minus 1 to the n and this minus 1 to the n simplify, and this x to the 2n and this x to the 2n simplify, and that leaves me with x squared times minus 1 times 2n factorial divided by 2 times n plus 1, the whole thing factorial, and I'm taking the absolute value. Well, as n approaches infinity, so n things are going to be positive, all of these terms are going to be positive, so I don't need the absolute values. Minus 1, take its absolute value, is equal to 1, so I'm not going to write the 1. And x squared, no matter what value I put in for x, is always going to be positive, so I don't need the absolute value for that. So then what I'm going to do is take the limit as n approaches infinity, the absolute value of a sub n plus 1 over a sub n, and that's equal to the limit as n approaches infinity of x squared of this 2n factorial divided by 2 times n plus 1, the whole thing factorial. And that's equal to x squared times the limit as n approaches infinity of 2n factorial times 2 times n plus 1, the whole thing factorial. And as it turns out, that's equal to x squared times 0, which is equal to 0, and that's certainly less than 1. So this thing converges for all x from negative infinity to positive infinity, because any x you tell me, I'm going to put into here, square it, then multiply it by 0, and that's equal to 0, which of course is less than 1. So I say that the radius of convergence is r equal to infinity.